Hi, I'm Kirk at the Tektronix booth, and I'd like to show you our MSO5 series. So this is our newest scope we introduced last summer. So it comes as 4, 6, and this model, 8 channels, anywhere from 350 megahertz up to 2 gigahertz. Has a 15.6-inch HD display, so now you can see a lot more of your signals than previous scopes. With the 8 channels, you have our new FlexChannel technology as well, so you can have either analog or digital channels. So each one of these can be 8 digital channels, so you can have up to 64 digital channels if you really need that. You also get 12 bits resolution. In high res mode, it actually goes up to 16 bits, so you get a lot of that resolution that you're not seeing in previous scopes. We're also introducing a whole new set of measurements with this scope. So you can see here, so we have one example of power measurements, and we're introducing some additional automated measurements. So you can see where you can add some of these other amplitude, time. There's a new set of power measurements as well. So if you're doing magnetic analysis, if you're doing jitter, anything like that, we now have the automated measurements available with this scope to do that. So beyond that, if we go over here, so now we're looking at our EMI, EMC pre-compliance and debug solutions. So we just introduced a new set of software that's used with our USB spectrum analyzers. This is called EMC View. And one of the things that customers come across is when they send out for compliance testing, they're not sure if it's going to pass or not a lot of the times. And you don't want to fail because it costs you time and money. So with the pre-compliance software, it allows you to pick a standard, and you'll see the limit lines for the standard. And then you can do a test on your board, and you can actually see where it fails. So you can see this, any sort of spike. So if it falls below or above the limits for that standard, then you can see why. And so once you do an analysis on this, you can actually pinpoint on your board where those emissions are coming from. And then that's when we want to move over into the debug. So using an MDO 4000C with the built-in spectrum analyzer, right, now you can look at your board, do a little bit more detail, and you can start looking at both the time and the frequency domain together. So what's unique about this scope is these measurements are time correlated, and we're the only scope that offers that. And so what that means is, as you can see here, right, we have a SPI signal that sends an enable for the VCO, and as we pan through this, this is what we call spectrum time. So here, before the VCO enables, you'll see there's no spurs, and then as we enable the VCO, now we start to see it spur at 2.4 gigahertz. And we can follow this as the PLL voltage stabilizes. We can see that eventually it will stabilize to a 2.4 gigahertz signal. Right, so it gives you a lot of insight as you're trying to debug your design and figure out what's going on, why is it failing pre-compliance, or if you didn't do pre-compliance, why is it failing compliance? Right, so this is a pretty unique solution for Tektronix. So with that, I will hand this over to Mike Mindy, and he can start talking to you about the probes. Mike?
Oh, hey Alex, how you doing? So awesome. Hey, so this is Mike Mindy. We're here at APEC 2018, showing off some of the latest and greatest test and measurement gear. So Tektronix has a wide range of probes. We do current probes from microamps, from hundreds of microamps to thousands of amps. We have the best in class. We design our own probes. Tektronix is the only test and measurement company that doesn't OEM their probes in the competition. I mean, from other sources. We design our own. We give you the best performance. We are the leading manufacturer of power probes, and really focus on it in shows at APEC. So we're introducing our broad range of current passive differential probes, really focused on the guys in GaN and SiC with our TPP 1000 probes, the best in class passive probe up to 1 gigahertz, lowest loading. Guys are using this for GaN. This is double the bandwidth of anything in the world besides this. We also offer high voltage up to 2.5 kV, 800 megahertz. And again, silicon carbide, GaN guys are loving it and using it for characterization. It becomes an industry standard. If we move over here, this is really our flagship. This was designed for the guys designing gallium nitride silicon carbide. This was really a result of the voice of these guys saying traditional probes don't work anymore, we need something new. So we developed the IsoView series. And here we have a demo of a half bridge using some EGAN devices, making a high side VGS, low side VGS, high side VDS, low side VDS measurement, all with isolated measurements. The banner spec of the IsoView system is 160 dB of common mode rejection. Nothing in the world comes close. And the bandwidths are we offer models from 200 megahertz up to 1 gigahertz. So we can capture those fast edge speeds that the GaN and silicon carbide guys need to see. We can also give them a measurement, they can repeatable, accurate measurement of the signal that they need to look at to characterize and optimize their designs and their systems. So here we have a picture of high side VGS, an impossible measurement, a lot of people think. But here we can clearly see this. This matches the simulation results these guys are generating. Before, they were seeing a bunch of noise and ringing from the common mode interference of their circuits. They didn't know what was real. So with IsoView, they can look at it and trust the measurement and repeat the measurement the next day and see the same thing. Also the voltage levels. We've increased the voltage levels this year. We were up at plus or minus 50 volts our first time at APEC. Well, this year we came back, we go up to plus or minus 2.5 kV. So we've also increased the input impedance up to 40 megohms. So lower loading on the circuit, lower differential loading. The common mode voltage, I can go up to 60,000 volts of common mode signal. So I can float this whole thing completely isolated from the scope. And we have 3 meters of fiber to extend it, to move my DUT further away from the scope so I don't have the interference into my scope. So thanks, Alex, and good luck.